Dear students, in the last class we discussed a few examples on equation of straight lines. In continuation with that, let's take few examples for today's session. Look at another example, example number 16. Find the equation of the perpendicular from the point P minus 1 minus 2 on the line 3x plus 4y minus 12 is equal to 0. Also find the coordinates of the foot of the perpendicular. In this context, we have to find the equation of perpendicular from a point to another line. So look at the sketch here. This is the point given minus 1 minus 2, from which we have to consider a perpendicular on the line this 3x plus 4y minus 12 is equal to 0, and this line is this one. So this line is given and the point outside the line is given. From this point to this line, if a perpendicular is considered, then the line PN is perpendicular to this line. So equation of this perpendicular we need to find. So here Pn, equation of Pn to find, if we look at the conditions, one information is given, that is a point P minus 1 minus 2 which is lying on this perpendicular or through which the line passes. So we have this information about the line to be required, that a point is given on the line or the line passes to the point. So point is given. Another information is given, that this line perpendicular to this line. So an equation of this line is given, that is this one. Since equation is given, from the equation we can have the slope of this line. So if we have slope of this line, then we can find the slope of its perpendicular using the condition of perpendicularity, because slope of this line into slope of this line is equal to minus 1. Product of the slopes of two perpendicular lines is minus 1. So using that condition, if we know the slope of this, automatically you can have the slope of this line. So let's get the slope of this given line. So given line is this one. If we express y equal to mx plus c form, and just simplify this, and y is equal to this, we got, and here y is equal to mx plus c, this is the form. And from this coefficient of x, it is minus 3 by 4. So obviously the slope of this line is minus 3 by 4. So slope of this line we have got minus 3 by 4. Minus 3 by 4. So if slope of this is minus 3 by 4, then we can find now the slope of Pn, because product of the slope of two perpendicular lines is minus 1. So therefore slope of Pn we can get 4 by 3. 4 by 3, because slope of one line is equal to minus reciprocal of slope of another line. So that product of the slopes m1 into m2 is equal to minus 1. So we have slope of the normal, that is Pn, is 4 by 3. So slope of the line Pn is 4 by 3. So equation of the line Pn now we can write using point slope form, because already one point is given through which the line passes, and the slope of the line we have got. So using point slope form we can have the equation of the straight line. The point is this and the slope is this. So point slope form, y minus y1 equal to m into x minus x1. Y minus y1, this is equal to m is this one, the x minus x1. X1 is this. So using this point slope form we can have the equation finally, and the equation is 4x minus 3y minus 2 is equal to 0. So this is the required equation of the perpendicular. So after getting the equation of the perpendicular, another part is there in the question, that is also find the coordinates of the foot of the perpendicular. That is the coordinates of the point n. N is the foot of the perpendicular. So we need to find the coordinates of this foot of the perpendicular, that is n here. So already we have got the equation of perpendicular Bn. So if we know the equation of the Bn and this baseline, then this point is foot of the perpendicular is nothing but intersection of these two lines. So this is the point of intersection of two lines, so which can be obtained solving the equations. So equation of Pn we know, equation of this line we know. Just algebraically, if we solve these two lines, then we can have the point of intersection, and the point of intersection is the slope of point of intersection is the foot of the perpendicular. So the equation, if we solve algebraically and solving this way, any method you can use, cross multiplication method, elimination method, substitution method, through any method you can use to find the values of x and y. And doing so, we have the coordinates of the perpendicular is 44 by 25 and 42 by 25. So this is the required coordinates of the foot of the perpendicular. Next, look at another example. It is find the equation of the straight line parallel to the line twice x minus 5y plus 1 is equal to 0, and which passes through the point which divides the line joining the points minus 4, minus 5, 4 and 3, 1 in the ratio 2:1. So here in this context, we have to find the equation of the straight line which is parallel to this one. One condition is given, that parallel to this given line and passes through a point. Point is not given directly, so the point is point of internal division in the ratio is given and points are given. So first of all, we can find the point which divides the line join of this and this in the ratio 2:1. So using section formula, we can find this point at which the line divides in the ratio 2:1. So let the point at which the line segment is divided in the ratio 2:1, the point of internal division, say x and y. So using the section formula, we get x is equal to this, y is equal to this, x is equal to 1 by 3, y is equal to 2. So using section formula, we have got the coordinates of the point of internal division. Also, the equation of the given line twice x minus 5 plus 1 is equal to 0. And since the line is parallel to this one, so we can find its slope, because it's parallel, then the slopes are equal. So we can find the slope, and to find the slope we have to express the equation is in slope intercept form. This y is equal to mx plus c, and here we can have the value of m is 2 by 5. So slope of the line is 2 by 5. So slope of the line 2 by 5 we have, and slope we have got 2 by 5, and the line passes through. So the slope of the line 2 by 5, and since the line is parallel to the given line, and slope of that line is definitely slope of the line to be required definitely the same, because that is the condition of parallelism. That is, the slopes of two parallel lines are equal. So the slope of or gradient of the required line is also 2 by 5. So point we have and the slope we have, so we should proceed through the point slope form to have the equation of the straight line. So the required line, equation of the line passing to the point 1/3 2 and slope 2 by 3, point slope form, and that is y minus y1 is equal to m into x minus x1. So this is the slope, and x minus x1 is the x1, and this is the y1. This. So after simplification, we have the equation of the straight line, 6x minus 15y plus 28 is equal to 0. So this is the required equation of the straight line. Next, have a look at another example. This example number 19. The points A, B, C are the vertices of a triangle ABC. Find the equation of the altitude of triangle through A. So this is the triangle, suppose ABC, and altitude through A is this one, AD. So this is the altitude. So we need to find the equation of this altitude. So as we discussed in the previous examples, the condition of perpendicularity definitely we need to use here. So equation of this line we need. So this vertex 2 3 it's given. So already one point in this line is here, that is 2 3, or this line passes to the point 2 3, same meaning. So we have a point on this line AD. Now if we have the slope of this line, then we can have the equation of this straight line using the point slope form. And if we have another point on this line, then also we can find the equation of the straight line using 2-point form. But there is no scope to have the coordinates of this point because it's altitude. It is altitude, not median. So the coordinates of this point we cannot find it because no ratio is given, and it is not median. So we cannot consider this as the midpoint of BC. So using the condition of perpendicularity, we can find the slope of this line AD. The coordinates of the point B and C, and this is a given. So equation of line BC we can find, but equation no need. We need only the slope of the line BC, and using 2-point formula for finding slope using 2-point, and that is this one. And this is the slopes formula. When 2 points given on a line, then we can have the slope of the line using this formula, y2 minus y1, x2 minus x1, or reversely we can use the difference of the y coordinates divided by difference of x coordinates. So thus we can have the slope of the line BC, that is 3 by 2. So 3 by 2 is the slope of BC. So using condition of perpendicularity, we can have the slope of AD, because if two lines perpendicular, then product of their slopes is equal to -1. So 3 by 2 is the slope of BC. So slope of AD will be -1 by this, and as for this one, condition of perpendicularity using this one, we can have the slope 2 by 3, -2 by 3. So this is the slope of AD, and this is the slope of BC. If we multiply this and this, we'll have -1. That's the condition of perpendicularity used. So thus we have the information about the line AD. One is the point lying on the line, and another is the slope of the line. So now we are ready to use the point slope form to have the equation of the straight line, that is AD. So equation of the straight line AD we can write using point slope form. Point is this and slope is -3 by 2. And we can write the equation directly. This y minus y1 is equal to m into x minus x1. x1 is this one, y1 is this one. So y minus y1 equal to m into x minus x1. So m means this is -2 by 3. -2 by 3 is the m into x minus x1. This is the simplification. We can have the final equation of line AD, and after simplification we have the equation this one, twice x plus 3y is equal to 13. So this is the required equation of AD. Let's have a look in another example. It's a little bit different, purely geometrical. Three sides of a parallelogram have the equations this one, this one, this one. Find the equation of the fourth side of if it passes through the origin. So it's parallelogram. The four sides are there in a parallelogram, and opposite sides are parallel, and equations of three sides given, and we need to find the fourth one. And another information is given, that is that the fourth line is passing through the origin. These three equations are here, and we can have the slopes of these lines definitely using y equal to mx plus c form. From this equation you can have y equal to 3 minus x. We see the gradient of this line is 2, and that of y is equal to this is 2. This line and this line, these two lines are parallel. Twice x minus 2 is equal to y, and y is equal to twice x plus 3. That is, this equation and this equations parallel, because slope of this equation 2 and slope of this equation 2. So these lines are parallel because their slopes are equal. So if this and this are parallel, then definitely the fourth side will be parallel to this one. This first equation and the third equation, they are parallel, means they are opposite sides of the parallelogram. So definitely fourth one will be parallel to the second one. Now what is the slope of second line? Is slope of this line we will be having, if we express y equal to mx plus c, we will be having the slope of this equation is minus 1. And knowing the slope of this equation, you can use in the fourth line to be required, and which is passes through the origin also. So the slope of the second line is minus 1, and the fourth line, that is the line to be required, passes through the origin. So slope is minus 1 and it passes through the origin. Therefore, using the point slope form, we have the equation this one, y minus 1 equal to m into x minus x1, and after simplification x plus y is equal to 0. So this is the equation of the fourth line of the parallelogram.